I will now switch to English to introduce our next speaker. He's Tõnis Paara from one of our neighboring countries to the east, namely Estonia. He represents the Finnish company Rapala, and for those of you who don't know Rapala, it's a company with a real rich history, and there's a good chance that even your parents or even grandparents actually used Rapala lures in their youth. Please welcome Tõnis Paara.
Yeah, hello. Sorry, I got a little caught up here, and I will share my screen. I hope everyone can see this. So, hi everyone.
Yes.
Yeah, my name is Tõnis. I am the materials specialist or engineer in Rapala. For you who don't know, Rapala VMC Corporation has quite a lot of products. We produce mainly fishing lures, but also fishing hooks, knives under the Martini brand. We have skis under Peltonen, fishing line, fishing baits, etc. Quite a lot of products. And of course, we have to keep an eye on all the products we produce, the materials they contain, first of all, for employee safety, of course, so that they would be safe to work with, and of course, customer safety. This is where the previously discussed lead and then the other materials come in. And we're going to have a little talk about the dangerous ones, restricted materials, and how to change outdated or discontinued materials. As we are a company with indeed quite a long history, we have quite a lot of ingredients in our products that become outdated or discontinued due to different regulations or just improvement of the technologies and materials as the day goes by. But let's go forward to the main issue, lead. Of course, everyone knows lead is toxic. It's bioaccumulative, which means it doesn't leave the ecosystem. It accumulates in different animals and therefore ends up back in us, which was quite surprising to me. I did a little bit of research that the amount of lead weights that were introduced to water were extremely high, about 97 to 170 tons in Denmark alone before they banned lead, about 660 tons in Germany and 1,000 tons in Poland. I think the time period was several years. I have the link down below, you can check it out. When we saw that the market was moving towards banning lead, because of course it had been banned in different products before, was in the beginning of 2000s, and it started from Denmark, which first brought up the subject of lead weights and lead in fishing products, that they end up in water, end up back in the ecosystem, and therefore back in us. From there, it was evident that the severity and the range of the ban will increase. Also, California started to discuss the banning of lead more or less in the same time region. And from there on, our work and research started. Of course, I was not in Rapala, so I don't know the full history. I have been given a short brief on what we have done. So I will show a little insight into what we have done and how. So lead replacement, first of all, we mapped all the critical properties of the materials, of the material lead that we need to have in our products. We mapped the similar materials or substances with similar density, similar hardness, melting point, because all of these play quite a significant role in our production process. First of all, of course, density, how the lure will play, where will the weight be inside the lure. So right now I'm talking mostly about the lead weights contained inside lures to make the play and their sinking action correct. So density was the most important factor for us when we searched for a replacement. But of course, price and availability. Before I heard that there was mention of tungsten, which is of course extremely dense, but also extremely pricey. And considering the new material candidates, so to say, we mapped their potential toxicity. Is there any danger for future regulation or restriction? So it would be a terrible situation when we find a new material, go through all the processes, and then find out it will be restricted or regulated a few years in the future. That would be a huge problem for us. But how the process itself went, first of all, we made proof of concept samples with the most promising candidates. Since we use quite a lot of different types of weights in different types of applications and production processes, we had zinc, brass, steel, tungsten, bismuth, all kinds of, even tin, and all kinds of different materials and their alloys. So we had quite a huge number of different lead replacement candidates, different alloys, different metals, and we started making proof of concept samples with them. We did full quality testing procedure. So with the best candidates, we ended up until the end-use tests to make sure we didn't miss any critical problems that might occur when lead is replaced with some other material. When these went well, we went on with small-scale testing with our existing machinery. This means that the critical part of replacing a material is how do you push it through your production system. All our different machinery, blades, whatever tools are used to produce the product so that these work well and don't create any additional problems. Of course, there were a lot of problems. So they had to switch different substitutes. They had to modify the production process, new molds, new tools. A lot of things had to be changed when the small-scale testing was done with the machinery. And when the modifications were made, we did large-scale production tests and large-scale quality tests. So the whole process has been quite intensive and extremely long since we have such a wide product range. It's quite a feat to change the one critical component of that product without changing the outcome, changing the quality and the properties of the product. Because for us, I think the main problem is we are known for some of our classical products that need to act in the same way. The game has to be the same, because if we change our existing product that we are well known for, we're going to lose a lot of clients. So we did a slow step-by-step introduction to the product range when we had made the proper adjustments of the material to avoid again finding out that we still have missed something, and when we launched the whole product range with the lead replacement to find out that something was wrong and we will have to either recall or answer for some serious quality issues. So about the process itself, for die casting or injection molding, we had 9 different substitutes in the large-scale testing, so to say, part. And the prices varied from 4 to 90 euros per kilogram, which is quite extreme. 90 is probably the tungsten version, but there were some extremely cheap options, so you have to take everything into account. It might perform extremely well, but if it's going to cost, I don't know, more than 10 times, 20 times more than the existing material and the lead we were using, then it's not worth replacing. For prefabricated components, we had 10 different articles, different alloys, bismuth, brass, and all these kinds of things. And from there also, the price difference of the different substitutes ranged from 3 euros per kilogram to 120. Again, the same thing. We can replace it with the best material, but no one's going to be able to buy the final product if we replace it with 120 euros per kilogram product. Of course, this again is different because the amount of weight or lead weight or lead substitute weight is different in a product. So then when we had a product where there is a lot of lead used, it's not reasonable to replace it with tungsten. The price will go extremely high. However, in some smaller lures where you only use a small portion or a small, basically pellet, you can go the tungsten way because the amount is so small, it influences the price so little, yet you get the good properties such as extremely high density. You don't have to make up for a lot of room inside the lure, for example. So at this moment also we have different lead substitutes. We didn't achieve one specific lead substitute that we use to replace lead. For different products we have different alloys and different metals that we use to replace what used to be lead. And all the changes we had to do in processing equipment was quite extreme also. We had to change the molds, jigs, different blades for tooling and modification or processing the lures. And of course we had to redesign some components of the lures for some lures, and for some lures we had to redesign the whole product completely because, again, as I mentioned before, for us it's most important that if we have an existing lure and we change some component of it, the overall performance and how it behaves has to remain precisely the same. We can't afford any differences. So this is more described here, I would say. I will go into the slide a little bit more detail, but the main problem is when we have a existing lure, it's difficult to change. I already talked about it, but it was easier for us to include this lead replacement in new products. So we didn't have to match exactly the previous performance. We could make a new lure from scratch and use the weight that was not lead already, so we can design it with already the new material in mind. So yeah, in the 2000s we used about 18 to 24 tons of lead per year. This was in 12 to 16 million products. For products that needed redesign due to material change, so basically we had to redesign the product to make up for the lead substitute. This was 85% lead-free by 2015 already. And products where redesign was not an option, so we had to, match the lure exactly, just replace the lead in there. This has been 93% lead-free by the end of last year, and the process is still ongoing. We are still replacing some of the lures or the lure components right now. But we are very confident we will get there quite soon to 100%, I mean. Now a little bit wider, chemical management, how we handle our dangerous chemicals or restricted chemicals. We keep a full database of all the chemicals and materials we have, safety data sheets. We try to stay up to date on all the regulations, but we have moved this to a partner of ours who keeps a digital database. So we have automatic identification when whatever component of some kind of chemical we use has a regulation changed according to it. For example, it's going to be restricted. We will get a notification and then we start work on replacing that. Of course, we always have continuous cooperation with our suppliers. If they know something is going to change, they will let us know. And we do our own internal research also regarding all the chemicals to find out which are in danger of being replaced and then finding replacements for those. The replacement procedure is basically the same: proof of concept, quality testing, then small scale, large scale, and introduce the new coating, paint, whatever, slowly to the existing product range. And yeah, this is right now extremely, relevant because a lot of paints and coatings are being regulated. A lot of components in there are being scrutinized and put into a ban list. So we're continuously working on replacing our existing paints and coatings and their ingredients. So in conclusion, what we do here to keep an eye on this is to keep an eye on the future. What's the direction? Which chemicals could be in danger next? So we could be a step ahead of the regulation. Can we already switch some dangerous or harmful chemicals already? Do we have the available alternatives on the market? And to do this, of course, you need a good overview of your existing materials and chemicals, where you use them, what's the purpose, do you have a safer alternative, do you even need this chemical? Yeah, this might not sound relevant for some companies, but for us, where the tradition is so long on how these lures are made, you have to remind yourself, why is this used? Are there new technologies we could use instead of this kind of chemical or material or process? And of course, reduce number of chemicals if possible, and materials, of course. Yeah, more or less, I think that's it in the short time I have. If you have any questions, let me know.